Welcome back for our second lesson this term with right angle triangles. Continuing on with this idea of reviewing Pythagoras and our understanding of Pythagoras. Now, last lesson, you guys did some questions on finding the unknown sides with Pythagoras, finding the longest side of a triangle, which was the hypotenuse, and then going ahead and also finding the shorter side of the triangle. And remembering the difference is that when we found the longest side, the hypotenuse, which was opposite our right angle, we added together a squared plus b squared, gave us c squared. When we had to find one of the shorter sides, and so when we had to use some subtraction, and we had to do the hypotenuse take away one of the shorter sides. Today I want to go through some steps for doing some problem solving with Pythagoras. So there's four things I want you to focus on when we are problem solving with Pythagoras. And the first thing is look for right angle triangles, okay? The diagrams that we're going to ask you to draw or that are presented to you, somewhere in there's going to be a right angle triangle for us to find, and we're going to have to do something with that right angle triangle. So look for right angles triangles. The second thing is, once you've identified and drawn up or put on the picture where that right angle triangle is, add all the information you can. Sometimes it's very obvious, the information that we're going to add to that triangle. Other times you're going to have to do some tweaking with some of the other numbers given to you in the question, and then you can find some extra information. So add everything that you can possibly add. And once you've done that, once you've added all the things you can add, there's going to be one thing left, one side left that you can't find, and that's when we're going to use Pythagoras to find that unknown. All right, and then finally, check your answer has the correct units. Most of these times that when we ask you these questions, there's going to be something is X meters away or so many centimeters tall, and make sure that our answer seems reasonable. If you get a flagpole that's 250 meters tall, there's a chance you might have forgotten to do the square root as part of your answer. So, does it seem reasonable? Does it make sense that something can be that tall, that long, whatever it is? All right, so let's go ahead and look at some examples here. All right, so two skyscrapers are located 25 meters apart, and there's a cable that links the tops of the buildings. Find the length of the cable if the buildings are 50 meters high and 80 meters high. Give your answer correct to two decimal places. So, the first thing here, I want to look for a right angle triangle. And the right angle triangle's got something to do with that cable. So if I was to, let's make that a little bit larger, and let's actually go that nice bright green, we can see that if I was to draw something along there we can see some kind of line. Can I make a right angle triangle with that? Well, if I come across here and straight up and down there, you can see there's that right angle triangle coming into play. So what we need to do now is, part two was let's add all the information we can. Well, I know that this building here is 80 meters tall, and that building there is 50 meters tall. All right, the difference between those two buildings is 30 meters. So what I have here is that my triangle there, it's got to be 30 meters tall. Now the other thing is I'm already told the length of the base of that triangle. I'm already told it's 25 meters. I can just bring that measurement up. So here what I have is I have a triangle, and I'm just going to redraw that a little bit so it's not as messy. So I have a right angle triangle that's 30, it's 25, and I've been asked to find, let's clean that up. Having a think, opposite our right angle. So that means I'm finding the hypotenuse. So if we think about it, c squared equals a squared plus b squared. In this case, the length of our cable is going to be 30 squared plus 25 squared. Right, so bringing forward our calculator, 30 squared plus 25 squared Well, that's going to equal 1525. So c squared is equal to 1525. Now, this is the part where I want you to pause and say, does this seem reasonable? If you want to stop as this is your final answer, what you're saying is that cable length is 1,525 meters between two buildings that are only 25 meters apart. Doesn't seem reasonable. So our final step to our answer is, remember, we need to square root it. So the square root of 1525 is equal to, well, let's go back to our calculator, the square root of 1525. It's equal to, and here we go, we've got an issue. We have lots of ugly decimal places. Remembering that if I wanted an exact answer, I'm just going to leave it as the square root of 1525. That's okay if I want the exact answer. But if we go back up to our question asked us to round it to 2 decimal places. Right, so to 2 decimal places, what I'm going to do, C is equal to 39.0512 blah 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 to 2 decimal places, which means I want to stop at the 5. After the 5 is the number 1, and because it's the number 1, that means I'm not rounding up, I'm leaving my answers the same. So what we've got here is 39.05 meters. So the length of our cable is 39.05 meters in length. All right, scrolling up, continuing on to example number 2 here. Example 2 says, find the value of k in the following figures. Round your answers to 2 decimal places. All right, so let's have a look at this. Well, in this question here, we can already see we have a right angle triangle for us, given to us. But one thing that I've noticed here is that k is all of this length, which I know that little part of that rectangle down the bottom there is 3. So I know k is going to equal 3 plus something, and that something is the leftover part that's inside our triangle. So let's add some information to our triangle. Well, that's 6. I know it can come across here. So my right angle triangle is 6 tall. The hypotenuse, which is the side opposite the right angle triangle, is 22. So what we are left to find is A. So I know that K is just going to be 3 plus whatever the value of A is. Right, so remembering C squared equals A squared plus B squared, let's go through and answer this question. Take a breath. Let's go. All right, so A squared plus B squared, which is 6 squared, is equal to C squared, and our C is our 22. It's our hypotenuse. So A squared plus 36 is equal to, and 22 squared is 484. Now, because we are finding a shorter side, remember that we need to now subtract here. So we're going to take 36 away from both sides. So we are left with A squared is equal to 484 minus 36. So if we minus 36, we get 448. All right. Now, remember that's A squared. 448 isn't our final answer. We need to square root it. So A is equal to the square root of 448. So A is equal to square root of 448. And we get 21.1660 blah blah blah. And remembering our question said I want to round it to 2 decimal places. So there's the second decimal place, and after the second decimal place is that value 6. And that value 6 is going to round up, make our answer round up. So we have 21.1660 0.17. Now, are we giving any units? If we look back at our question, there's no units. So we're almost finished here. All we have now is that we now know that the value of A is 21.7. 21.17. We know that's the value of A, but it's not what K is yet. So finally, answering our question there, I want a different color. Let's go purple. Therefore, K is equal to 3 plus 21.17, which is 24.17, and it's units, whatever length that we wanted. Right, so just quickly running back through what we should be doing with problem solving type questions is, first of all, we should be looking for where is the right angle triangle. Can we find one? Let's draw it in there. After we've drawn the right angle triangle in there, or identified it if it's already drawn, let's add all the information we can to that triangle. What is the short side? What are the lengths of the two short sides? What's the length of the hypotenuse? Identify what we need to find. Once we've done all that, we're going to use Pythagoras' theorem to find what we don't know. And then finally, we're going to check our answer seems okay, seems reasonable, and that, it's in the correct units. If the question said in meters, we've responded in meters. So questions I'd like you to do from the Cambridge textbook, you need to do exercise 4D. Once you do question 1, 3, 6, and 8, all of those questions there. And then on this worksheet here as well, you've got 2 additional questions. This question about a straw inside a can, and this question about how tall someone's house is. At the end of this worksheet, there is also the solutions for you to mark those questions. Once you've done that, you correct all your work from the solutions, fix any errors in your working out, take a photo, submit your work via the assignment tab on Canvas, and again, that needs all to be done by Friday afternoon. Good luck with it, Year 9. Talk to you later.